Hello everybody, welcome to the Robust Engineers. In this video, we are going to see how to create the strength model and service model. Now, for strength model and service model, what do you understand by strength model and service model? So basically, strength model is used to design their structures. If you have to design our RC building, then we have to apply the strength model. Okay, and for service model, to perform the serviceability checks like the displacement due to earthquake, displacement due to wind. Okay, so for that, IS code has given some of the stiffness modifier. Now, basically, why we apply this stiffness modifier? The basic of this stiffness modifier is to generate the crack moment. So at the time of the earthquake, it may happen that our structural members get cracks. So that this cracked section will leads to the cracked moment of inertia. That's why we apply the stiffness modifier in our entire structure. We have two types of stiffness modifiers, strength and serviceability as discussed earlier. Okay, so from where we can get the stiffness modifier? We have IS 1890 2016 as well as IS 16700 2017. Both the code has made the provision of stiffness modifiers. Okay, so we will refer IS 16700 2017 for the stiffness modifier because it is properly tabulated and easy to understand. Okay, I'll go to the IS 16700 2017 table number 6, correct RC section properties, clause 7.2. Okay, in this they have unfactored load, which means serviceability checks for serviceability, and factored load for the strength. Okay, now we have the structural elements, slabs, beam, columns, and wall. In both the cases, unfactored and factor, the area would remain same. 100% area will consider for slab, beam, column, and wall for both cases. But moment of inertia will vary for unfactored loads such that serviceability. We are considering only 0.35 of the gross moment of inertia. Only 35% we are considering. The actual capacity, we are considering 35%. For slabs and for beam, we have 0.7. For columns, we have 0.9. And for wall, we have 0.9. Okay. For factored load, this, this percentage will vary. For slab, we have 0.25. And for beams, we have 0.35. For columns, we have 0.7. And for wall, we have 0.7 of the total moment of inertia. Now, some of the structural engineer practice the slab to be designed for gravity. Some practice that it may take earthquake load. If we are designing our slab for earthquake load, then we have to apply this stiffness modifier. If we are not designing it for the earthquake load, only gravitation, dead load, and live load, then we don't have to apply any stiffness modifier to our slabs. Okay, that we'll see in next videos. In this video, we are going to see how to apply this stiffness modifier in our structure. First of all, what I'll do is I have opened this project, Etabs project. Okay, I will save it with different name. First, I will save it with serviceability. I would say no. Okay, first we'll create this strength model. Okay, for that you have to go to select object type. We'll select the beams. Okay, we are now creating the strength model. Select the beam. Go to assign frames. This property modifier. For the property modifier, we have moment of inertia as per the IS 16700. For factored load, set the strength model, we have 0.35. So we'll apply 0.35, okay, in minor axis as well as on the major axis. We have to apply on both the axes. Now, in case of the torsion, most of the torsion coming in our building is secondary torsion, not primary torsion, which can be taken care by the slabs. And also what we generally do is if our beam is connected to the slab behind, so this torsion force will convert it into tensile force and taken care by the slab. So we will apply the stiffness modifier of 0.1. Only 10% torsion we design for safer side. You can take 0.01 also, but for safety we are considering 0.1. Okay, all the way we are neglecting, but you have to always take care that if your beam doesn't have slab behind, then you don't have to apply this stiffness modifier because the torsion then only will carry by the beam only. Okay, so you have to keep in mind that if the beam is not connected with the slab behind, then you have to take this torsion constant as 1. Now in my case, I don't think that I have this type of condition occurring, so I will take 0.1. Okay, then apply. Okay, property modifier has been applied to our structure. Now I will select OK. Then you have to go to deselect. Everything will get deselect. Okay. Then you have to go to column, select, go to assign, go to frames, go to property modifier. Now we design column for torsion. We do not have to change any value for torsion. Only the moment of inertia about minor and major axis should be changed. Now we'll go to IS 16700. We have for column as 0.7 of the gross moment of inertia. Then we'll apply 0.7 here and 0.7 over here. Sorry, 0.7. Then apply. Okay. Now deselect. Now we'll go here and select this wall, because we have the core wall over here which is taking care of the lateral load as well as the gravitational load. Then we have selected the walls, go to assign. Now wall is a shell element, so we'll go here and select the shell. Stiffness modifier, since it is taking both earthquake as well as the gravitation load, so we have to apply for membrane as well as for the bending. Okay, so 0.7 as per the IS code we are applying. Yeah. Okay, do not have to change any value in the shear and mass, weight, etc. will remain the same. Only the bending and membrane would be changed. Then we'll apply. Okay. Now, as we have discussed earlier that we are designing our slab to take the gravity load, then we will deselect all this thing. Select floors. We have to apply the stiffness modifier to the slab. Go to assign shell. Then stiffness modifier. What are the, since slab is a bending element, so it is governing in bending. So we would change the stiffness modifier of bending. Now what is the stiffness modifier? Is 0.25. Go here, apply 0.25, 0.25, 0.25, then apply. So this is how we have created our strength model to perform the strength check and to design our structure. Now for checking our structure, we have to create the service model. Now I'll go here, file, save as. I'll save this project to service. Okay. Service. We'll save. Procedure would remain same, but the stiffness value, the moment value would change. IG would change. Okay. Now I'll go here, select floors, go to assign shell, stiffness modifier. What are the stiffness modifier for unfactored load? We have 0.35, 0.35 in the bending. We have 0.35 in the bending and 0.35 in the bending. Okay, then apply. Okay. Go to select, deselect everything. Then go to select walls. Go to assign shell, stiffness modifier. We have 0.9. As per the IS code, we'll apply 0.9 over here. Then 0.9 over here. Then apply. Okay. Then deselect everything. Go to select columns. Select assign. Column is a frame element. Select frame. Property modifier. Torsion. Don't have to change any torsion. Moment of inertia 0.9. About minor and major axis. So we have changed accordingly. And then deselect everything. Go to select beams. Go to assign frame. Property modifier for torsion 0.1 as discussed earlier, and for beams we have 0.35. Okay. Oh sorry, 0.7. We'll apply 0.7 over here, minor as well as in the major axis. Apply. Okay, then deselect everything. This is how we create the service model as well as the strength model to perform the check accordingly. Thank you for being with us. For more content, please subscribe our YouTube channel. Thank you.